This video is going to cover question number 1983b2. And so take a minute to read through the problem. Notice that we have a 2 times m, 2 mass, and we have a 1 times m. And so that's going to, once again, give us a different ratio of how fast each is going to go. So I'm going to set it up with a basic momentum equation. Doesn't really matter which one you call m1, m2. I'm going to call this the 2m, and it is going to hit the other one, which is going at 0 at the point at that time because it is just sitting there. And then when it hits it, they're going to hit and stick together, and so that's a 3m, and they have the same velocity because they are together. So now all I need to do is just solve this for final velocity. So I'm going to divide each side by 3m. So when I solve that for final velocity, I get 2/3 of the original velocity. And again, that should make sense. This has a certain velocity. When it hits that one, they're going to slow down a bit, but this one had a greater velocity, so they're only slowing down by 2/3. 2/3 the original velocity is what the final velocity is. Okay, once again for part B, we could think of this as an LOL chart. And we have some kinetic energy going in with no spring energy. So it goes in with some kinetic energy, but the spring has none. It compresses the spring, it comes to stop because it's as far as it's going to go. So it's now stopped, so it has no kinetic, but it does have spring energy. And so in other words, our kinetic energy is equal to our spring energy. So we can set it up with this equation here. In this equation, I'm going to cancel my 1/2s just because that's going to make it so much easier without those fractions, and they can cancel. So let's just get rid of those. My mass, I'm talking about 3m, the whole thing together. My velocity is the velocity I just figured up here, 2/3 VO. And I need to square that. It says in the problem that they're just calling the spring constant K, so I'm just going to leave that K as K, and X is what I'm actually trying to solve for, so I'm just going to leave that as an X. So I'm going to simplify this as much as possible. So when I square that out, I get 4/9. The 3 and the 9 reduce down to 1/3. So I'm down to a 4 in the numerator and a 3 in the denominator. I still have my m, I still have my VO. That needs to have a square on it. I need to divide by k because I'm trying to solve for x. So I divide by k and I get 3k in my denominator. I need to take the square root because I have this squared. I want just the x, and so that is my final answer. So the maximum distance is 4m times VO over 3k.